Yaskawa. Welcome to the MotionWorks IEC OPC server e-learning video. Hi, this is Matt Pelletier with Yaskawa America. Now, if you're wondering what OPC is and how to use it with the IEC controller, then this is the ELM for you. I'm going to have two major parts here to this presentation. First is an overview, and then second, I'll hook up and connect a live example of using the OPC server. So first, let's look at an overview of OPC. OPC stands for OLE for Process Control. OLE means Object Linking and Embedding. If you're a software programmer, that probably is very clear to you. To put it in layman's terms, what OPC means is it's a standard format that hardware can use to communicate to a PC over Ethernet. And as an analogy, think of Windows and printers and printer drivers, where the printer is analogous to the machine controller, and your driver is basically what the OPC server is. Way back, if you think before, the software developer used to have to write a driver for every printer that they wanted to support. For example, AutoCAD, WordPerfect, each of those software developers had to write a driver for each model of printer, Epson, HP, etc. Soon that was realized that wasn't very efficient, wasn't very easy to do, made it difficult to develop the software. And so you developed the concept and the standard of printer drivers, where the manufacturer writes a driver. And then that driver delivers and receives the information according to a Windows specification. So basically every printer is made to communicate to a PC through that driver, so that it communicates through the driver in the same way. So this is what OPC does for controllers. It communicates the controller's data according to a specific standard. So you can probably now imagine the benefits of having this easy access and standardized access to a Windows programming environment. Now, if you write your program in VB or Visual C++, etc., you will be able to access the data of the controller in the same way, no matter what type of controller you have. And so now you can very easily use the PC for data logging. You can use it as an HMI, or even have part of your program or your decisions be made by a PC. In a sense, you're taking the place of the higher level PLC or HMI. So here's the way it works from a top level perspective. The controller, the IEC controller, communicates to the OPC server, and the OPC server communicates between an OPC client and the controller. So this is how you get the client, the PC software, to communicate through the server to the controller. Keep in mind here, the server is really just a software application running on the PC. It's not a hardware device. It's a software application, and likewise the client is also a software application that's been written. And so you have each of these three entities communicating either on the same PC, or it can be over the Ethernet. The client can exist on the same PC, or you can, over Ethernet, connect another client, or even several clients, all displaying maybe different or the same information, updating or even sending variables or commands down to the controller through the OPC server. In the same way, you're not limited just to one controller. You could have several controllers out there, and that server then handles each of those controllers. Every manufacturer who makes an OPC server program is going to be making that specifically for a certain type of hardware. So Yaskawa has made this OPC server, and it works exclusively with the MP and IEC series controllers. And if you had a third-party controller in the system, you would just need to run a third-party OPC server that's made to interface with that controller, and then your client could just as easily display information from different controllers of different manufacturers, all rolled up into one. So you can really see here that there's the OPC server concept, and the OPC standard really opens up the power of the PC for machine data acquisition and control. So what do you need to get started and take advantage of OPC? The first thing you need is Yaskawa's OPC server software package, which is our part number pde-u-opcpa. And if you buy quantity licenses, you get a discount. There's also, I believe, a 30-day trial version. And then you'd also need to develop client software. This is where a lot of times the OEM will be writing their own software for the machine. And there are also, if you take a search out there on the internet, you'll see there are different configurable software packages. And one that I'll be using in this presentation is called OPCware XL, made by the company OPCware. I got the trial version of this one, and it uses Excel to display your data, and basically exists as a plugin to Excel. And so OPCware XL lets you do any of the things that you're used to with Excel to manipulate the data. And that's it for the overview. Okay, now I'm going to demonstrate a simple but full working system using OPC. First, let me explain what I want my application to do from the user's perspective. I want to be able to open an Excel spreadsheet, and using the buttons I've created, I want to be able to control my machine. So let me switch to Excel. So here it is. This is an Excel sheet that I've created previously, and I want to be able to turn the servos on. You can see I have here my two controllers, and I want to be able to turn the servos on. I'll click this button, and that sets a 1 to these cells. That should turn the servos on. I want to be able to set the speed. I can adjust the speed sliders here and set the speed of each move. And I want to then hit start and have the motors do a simple indexing move at the speed that I've given to them. And then below here, every time it completes a move, that's a part created, and I want to see a live update of each of the motors and how many moves or how many parts that they've done. And again, this is the OPC client that we're looking at, and it's called OPCware XL. It's a plugin to Excel, and I'll be showing more of that later. The most simple desktop setup to just test out and run the OPC server would be simply just to connect your PC to your controller as usual, and then on your same PC run the OPC server and run the client software. So if you want to try this on your own, that's going to be the easiest way for you to do that. But I want to better illustrate really the power of OPC, and so I'm going to use a more complete setup using multiple computers, more of like a complete installation. So in this setup, I'll be using two controllers, and these controllers are basically just part of our standard demo, and each controller has two servo axes, two amplifiers, two motors, two servo axes each, so 4 axes total. And these controllers are part of an Ethernet network using a common Ethernet switch. You can see the IP addresses listed above, .41 and .42. Now I have my laptop computer, and I have a simple program that I'll be showing here, simple indexing program in each controller. And then I'll have a separate laptop as the OPC server running our OPC server software. And that laptop basically just sits there and runs the server. And then finally I have yet a third laptop as the OPC client. And you could have even more than one OPC client, remember. You could have as many different nodes or clients you distributed between the different PCs or the same PC. There's really a set limit on that. And also note, if you are going to set something like this up, it's important to have a plan for your IP addresses. That's why I've listed all of them here. Controllers are 41 and 42. We're going to have to remember the OPC server, that's 192.168.15.83. See, I'm using a .15 network. So first let's look at the controllers, and I want to point out just the very simple program and what you need to do in order to interface to the OPC server. Here is my program that's running on each controller. Both of the controllers have the same program. You can see it starts with just your normal MC power 1, MC power 2, and I have some global variables for enable and for the status to see whether I'm enabled or not for each motor. I'm calling my motors left and right, and the G underscore just is confirming the fact that they are globals. And then scrolling down here to the main body of the program, it's very simple. I just have a move relative followed by a timer, so there's a delay. It's about 500 milliseconds. And then that just finishes with a counter, and I'm counting the moves right here in the program. And I'm doing the same thing for the left motor as I am for the right motor. You can tell it's the exact same program. So this is just a basically repeating indexing move, and all we need to do is give it the start bit, starting left and starting right, give it that contact, and it'll just keep going as long as this contact is held on, either start left or start right. So to send variables to OPC, you really have two options. By default, every single global variable is marked for sending to the OPC server. So what you could do under the default here in MotionWorks IEC Express, if you want to send a variable, make it a global variable, and then that will be sent to OPC. Now, you don't have to do it that way. In fact, so it's a bit more efficient, so I'm going to show it, and I do want to show that this is also in the help. If you want to know a little bit about OPC, go to the MotionWorks IEC Configuration help, and if you look here, you'll see that there's an Ethernet section, section 1.9, and OPC server is the last area. It gives a good overview of what OPC is, and then it shows this part that I'm going to show, which is how to mark your variables for OPC. It amounts to going to your resource settings and changing that option. So I'll show that. I'll go to my project tree and go to the hardware tab, and I'll then click on the resource, that's the controller, and look at its settings. And you can see that the settings here, the default setting is for OPC all global variables, and I've changed it to marked variables. And that means that I need to mark every variable I want to send over OPC with the OPC checkbox. And that's also very easy. If you look at the global variables, now you can see that I've marked for these status right, enable right, status left, enable left. All over here to the very right, there's the OPC column. And this OPC column, I've checked the box. You see, I have not checked other ones. Those will not be sent over OPC. Now, you can also send variables that are not global. And so I've opened up here the local variable list. And you can see I'm sending the velocity for the right and left motor over OPC. I'm also sending the start command, the start bit there, that contact, over OPC. And I'm also sending the counter for the right and left motor, that part counter. So once you have your program and your variables marked for OPC, just do your normal make and download and be sure that the program is running. And I can even monitor that here. I can see that I have values for my variables in my debug mode, and I can see the status here of my program. Next, I will move now to the PC with the OPC server. Now I've moved to the OPC server PC, and all I've done here is just install the OPC server, and I'm going to show now the rest of the setup. Notice I do have connection to the controllers here. I've connected to .42 on one interface, and I've connected to .41 in the other tab here. So I do have communication. I've verified I have communication to the two controllers through this PC. Now, the first note of interest is it's a good idea, at least for your first startup, to disable the firewall. And to do that, the way I do it is you right-click here at the bottom of the system tray, change firewall settings, and just be sure that you do have that set to off. If you have it on, it's very likely that the communication between different computers will be blocked. So I'm going to leave it at off. And now we're ready to start the OPC software. The first time you start it, you'll need to go to Programs, Yaskawa, MotionWorks OPC servers, where it installs to here, and you need to configure it, and they call that the OPC configurator. So in the configurator, you have your OPC project. What you need to do is you right-click on it, New Resource. Remember, resource is a controller, so you're saying New Controller. And then on that resource, you need to give it a resource type, which you call it MP2000 series. You change the settings. And here's where I will use the IP address, 192.168.15.41, and TCP IP. And you click OK. That's really it. And I'm going to change the name of this one. You just click 2 times here and change the name. I'll call it MP2300 SIEC. I'll just remind myself that it's IP address 41. And I'll do the same thing then for the other controller. New resource. Click on the resource. Select the resource type, MP2000 series. Go to settings. Change the IP address. 192.168.15.42. And click OK. And I'll change my name on this one too. So I've got 2 controllers here communicating to this OPC server according to these settings. That's it. You close the configurator and then go to the same area here, Start Programs Yaskawa, OPC Server, and run the server here, OPC Server 2.1. And when the OPC server is running, you're going to see that down here in the system tray, and that's how you know it's running. Now you can look at the status, and it's very helpful to do that from time to time. And to look at the status, you right-click Info Statistics. And this tells you the health of your connection. And you can see here my resource. It tells me the PLC state, the items in use. There's 4. Those are the 2 variables for servo on for each axis and confirming servo on. And it tells you the PLC state is run. So that's good. And as far as the server PC goes, this is pretty much it. I mean, you really don't have to touch it again unless you do want to maybe confirm what the status is of the controllers, or if you want to confirm that you do have your clients connected. We'll come back here and look at this as well. So now that we've looked at the OPC server and we have that set up and running, let's look here at the OPC client and how to set that up in this case. So here we are now finally back in the client, the OPC client. Again, this is OPCware. You can see there's an Excel menu for this. This is where you have all of your controls. The first step to using this, like we did in the server, is check your firewall. So I'm going to right click and change firewall settings and just confirm that I have my firewall off. I had that on at one point and it did not work. The next thing that's a good thing to check is let's just check that this PC has communication, Ethernet communication to the server. So one way to do that is you hit Start, Run, and type CMD. And then what you want to do is ping the server. So I'm going to write ping. My server is 192.168.15.83. And you can see when I do that, I'm getting good communication, 0% loss. So that's good. That means that this PC does have Ethernet communication to the server. Next is just an example of how to use this particular client, which is the Excel plugin, OPCware. And the way that works is you go to their configuration. So the way this software works is you add the server by clicking Add Server and then browse for the remote PC. I just need to type in that IP address again, 192.168.15.83, and wait for that to connect. And there it is. The OPC server comes up as opc.out.pcos.21. And so I'll just connect to that server. And so there it is. There's a server in the tree here of this software. And if you would look back at the server PC and you would do a refresh, you'll see that now we do see a connection to the server in the status. And it comes up as the client, because we are right now in the client with this OPCware XL program. The next step in this particular software is to add a group. And I'll call this 41 underscore left motor and add that group. And then I'm just going to do that for each of the controllers. So here I've just created groups for each axis. So I'll have my variables separated in groups for each axis. Really, you could make the groups however you want to. I just decided to do it this way. And then for each group, I will add the variables from the OPC server. Add item. And here you can see I can browse through this OPC server. One of the benefits of OPC is it brings those names of those variables right in for me. And I really don't have to do anything special in order to see that. That's part of the OPC standard. Now in this software you hit validate select, add item. And in my main program you can see it's broken out which variables are in the global and which are in local programs. Main is one of my local. So I've got count left, start left, velocity left. I'll validate and add those. Okay, so I just need to do this for each motor, and I'll have each of my motors in there. So now I didn't show it all, but now I have the variables for each of the groups, and you can even see I have the value. It knows the value of each of those. Some of them were different from one to the other. It tells me the quality of the signal. It tells me which resource it's coming from. So this is all standard information that you're going to get from the OPC server, no matter what client you are configuring. And in fact, if at this point you would look back at the server PC, look at the statistics again, you'll see that each of these 4 groups are already connected and communicating these variables. So the feature of this software is that we can link any of these data to a Microsoft Excel spreadsheet. And so that's what I'm going to do now. I'm just going to show a few of them. So where do I want to link the velocity left? I'll link that to here, left motor, speed. And just when you just hit apply in this one, I'll hit connect the start. I'll go down here to count. I called it count, but I called it parts here in my sheet. Go to status. Status was the servo status, confirming that it's on. And then here the enable left. So you can see here it's put that into the appropriate cells. I'll just do the rest of them here quick. We'll take it from here. So now I've gone through one by one, and for each motor I've applied this. So you can see here each of these are yellow. I'm also monitoring my program on one of the controllers. My other PC. This is the moment of truth. I'm going to use the client and turn on the servos with my nifty little button here. And look at that. I set the servo on. I received the servo on confirmation. I'm now going to start the motion. I'm going to hit start. You can see that the moves are starting to complete. My graph is updating. And just to show a little bit more about how this works, I'll turn up the speed here of one of the motors. Now the way this one works, you do have to do a write in order to send that over and update the speed. Of course, now you can see that left motor on controller 41 is taking off, and that's represented in the bar graph. Maybe I'll do the same thing here for right motor, number 42. Anyway, you can have a lot of fun here. I'll do a write all. And that just ensures then that that data is being written. And this is the power then of the OPC client. You can see I've done something very simple here, just taking data directly out and displaying it a little bit differently, making a little interface for it. So really you're limited only to what you can do within a Windows program. In my case, I'm limited to what I can do within Excel. Maybe I'll speed up a couple more of these other ones. I'll max out left motor. And I'll put right motor a little bit higher, right all. So now I've let this run for a while, and I'll just show a little bit more of what I can do here with this client. I'll hit the start button again. That stops my motion and resets my part count back down to 0. I can confirm that on the debug screen. And I can turn off the servos. This time I'll show the servos turn off also in the debug screen, and off they go. You can see here the power of OPC. This concludes the MP2300 SIEC OPC server e-learning video. For more information, please contact us at 1-800-YASKAWA. Go to yaskawa.com or email us at training@yaskawa.com. Thank you very much.